Okay, here are two examples of problems like you'll see on the final that are associated with the last week or so of class. These were solving simultaneous equations. So I want you to be able to do elimination and to use the matrix method. So this example here is just using substitution. So we're going to figure out which values of x and y satisfy both of these equations. So I'm looking at this and I'm looking for one where I just have x or y by itself. Just makes it easier substitution and I don't have to deal with fractions. So you can see the second equation has y. So what I'm going to do, I'm going to take the second equation and solve for y. So this goes to the other side. It becomes positive 4x. So you get positive 4x minus 4 is y. And then you can substitute back into the first equation, the other equation. And what that substitution allows me to do is to now have this all in just in terms of x. And we just have to figure out what x is. So we have 3x. 7 times 4 is 28, so we get 28x. 7 times 4 is 28, so we get negative 28 equals 34. And 28 plus 3 is 31. So get 31x. And then I'm going to move this to the other side, so you get 34 plus 28. So this comes to the other side, becomes positive. And that's equal to 62. And then you divide both sides by 31. And you get x is 2. And then you go back to your substitution equation that you used and plug in the value of x that you calculated. So 4 times x, which is 2, minus 4, that's going to be 4. So you get the solution is x equals 2 and y equals 4. And what that means is if you plug x equals to 2 and y equal to 4 into each of these equations, they'll both be satisfied. Okay, the next method is using the matrix method. So I've got these two equations. So what we're going to do first is you're going to write this as what we call an augmented matrix. It means we're augmenting these coefficients with these two coefficients. So the first equation becomes 4 minus 1 minus 12. And the second equation is 1, 3, 10. And remember what we're trying to do. We're trying to get a 1 here, a 0 here, and a 1 there. And the other ones will be what they are based on the row operations. So first thing we look to do is see if we can just switch rows and get a 1 in the upper left-hand corner, which we can in this case. Now, if you can't do that, then you just have to divide. Say this was a 2, then you wouldn't necessarily gain anything by switching them, and you would divide the first row by 4 to get 1. So you either can switch rows, or you can divide the first row by the coefficient here. Okay, the next thing, now that we have a 1 in that location here, we're going to take row 1 and multiply by negative 4. That's so when I add these two rows together, this row multiplied by negative 4 and this row together, I get a 0 in this location. So I'm going to take row 1, multiply by negative 4, add to row 2, and replace row 2. So let's write row 1 down first. So you get 1, 3, 10. Okay, then we'll take row 1 times negative 4, so that's 4, negative 12, negative 40. So each one of these numbers multiplied by negative 4. Then we'll write down row 2, which is going to be 4, negative 1, negative 12. We're going to add those together. So you, something's wrong here. It should be negative right there. Okay, negative 1 times negative 4. It's negative 4. Okay, add those two together. That goes to 0. This becomes negative 13. And this becomes negative 52. So that's this. And then we're going to replace row 2 with that result. So you leave row 1 the same. Replace the second row by 0, negative 13, negative 52. So now we got 1, 0. The next thing is to get a 1 here. Well, all you have to do to do that is you just have to take row 2 and divide by negative 13. So let's just write that down. Row 2 is 0, negative 13, negative 52. So row 2 divided by negative 13 is 0. 0 divided by negative 13 is 0. Negative 13 divided by negative 13 is 1. And negative 52 divided by negative 13, that's equal to positive 4. So we get 1, 0, 1, 4 for the second row. And that's where we want to get for these two equations and two unknown problems. So once you get here, this says 0x plus 1y equals 4. 1y equals 4 is the same as y equals 4. So that's my first solution. And then I can go back and plug that into either one of these equations. Well, actually, we're going to use the one that's represented by the first row. The first row is 1x plus 3y is equal to 10. And we use y equals 4 in there. So I get x plus 3 times 4 is equal to 10. X plus 12 equals 10. X equals negative 2. So my solution is x equals negative 2, y equals 4. So those are two things. There's two problems, one of each. The test is on this material.